I think it's time to get started with the next installment of Little Shop of Physics Live. And today, we're going to talk about oscillations and waves. And I'm going to start by introducing just a couple of quick principles. So my name is Brian Jones, and this right here, we have this yellow ball, and it's at the end of a spring. And it's got its happy place. This is its equilibrium position, we say. And if I pull this ball down, the spring pulls it back. But when it gets back to its happy place, it doesn't stop there. It keeps on going. It keeps on oscillating. And this is the situation that gives us oscillations. I have something that has its happy place. It's held in place by something which is springy. And if I displace it a little bit, it bounces back and forth. And it's got a certain frequency, a certain rate that it likes to bounce at. Now, something else I'm going to show you. If I take my hand and I wiggle it just a little bit, if I wiggle it quickly, not much happens. If I wiggle it slowly, not much happens. But if I wiggle it at exactly the frequency that the ball likes to oscillate at, the ball goes crazy. And that's something we call resonance. So if I take something and I vibrate it at the frequency that it likes to oscillate at, I get a really big oscillation. Now, another kind of thing that makes a nice oscillator is a pendulum. And we have here a little yo-yo, and it's got its happy place. If I pull it to the side, gravity pulls it back to the center, and it swings like that. You are getting sleepy. You're getting very sleepy. And parents, you probably are, because you're probably not sleeping very much with having to take care of your kids and do a job and all that. Shout out to all the parents who are working so hard in these days. We are thinking of you. So here's my second kind of pendulum. And if you want to do a pendulum like this, well, heavens to Betsy, you have several of them connected to your body. I want you to think about this. When you walk, your arms swing back and forth, and they swing like pendulums, kind of swinging back and forth as you walk. And if you want to make your arms go faster, like instead of walking, you're running, what you do is you make your arms shorter, and then they go faster. So you go slow, and this is in time with my walking. Or they go shorter, and it goes in time with my running. And that's just because they're working like pendulums, and a shorter pendulum goes more quickly. So that's the kind of thing we're going to be talking about today. And next up, over to Brenna for our first oscillator. And everything we're doing today, we're going to show you how you can try at home. Brenna, take it away.
Yeah, so here I have a drinking straw. And this is one of my favorite things that I've ever learned in Little Shop. You're going to take your drinking straw, and you're going to cut each side of it to where you get a point. So see, I kind of have a point there. And then what I'm going to do, and I'm going to take off my face shield. We got plexiglass here. And I'm going to bite it. Hold on.
Oh, very nice. Very nice.
So we got some air bouncing around in there, and it bounces along the length of the straw, and then it really likes it, so it makes a noise. And I think Brian's going to ask you a question about what will happen.
So Brenna is going to take that straw, and she's going to cut it shorter. And when she cuts it shorter, here's my question for you. Will that make the pitch higher? Will it be the same, or will it be lower? Go ahead and click your choice. Oh my gosh. Oh my gosh. The responses are coming in like crazy. We're 61% in favor of higher, 30% for lower, and a distinctly passionate minority is in favor of it will be the same. Ooh, it's higher is up to 65, lower is holding steady at about 27. Be the same, that small passionate minority is growing. They're reaching out to other people. But the consensus choice is it's going to be higher. Now what we need to do, of course, is let's do the experiment. Brenna, take it away.
Hold on. My straw is giving up on me very quickly.
Okay, and keep going, higher, keep going. And I think it is higher exactly as we predicted. Perfect. Well done, everybody. Now we're over to Maud. And Maud is going to do another oscillation. Now, in Brenna's case, it was basically the wave. There was a wave inside the tube that was like bouncing back and forth. That's what made the oscillation. In Maud's case, we're going to be looking at air sloshing back and forth in bottles.
Yep. And so to do this at home, you want to make sure that you get a bottle that has a really distinct change between the bottle and the neck of it. So you want something really where you can see the difference between this part and that part of it. And so there are a bunch of different bottles and like sizes that you can try. Things like sounds kind of like a whistle. And then if you have something with a really, really long neck and a really weird wide bottom,
sounds a bit lower.
Kind of weird sound there. Something like this. Kind of sounds like a train whistle to me. I don't know about y'all. And then our biggest one here.
Oh, nice and low. That one's nice and low.
Really low. But I have some water here.
Oh, wait a minute. And Maud is going to pour water in. So Maud, give us the pitch. Give us the pitch. So go ahead and blow it again. Let's get the pitch. Okay, nice and low. Everybody remember that. Maud is going to pour water in, and we're going to give you a poll as she does it. Is that going to make it higher or lower when she pours water in? So she's poured some water in. Let's see what people are voting. Ooh, man, this is evenly split. It's evenly split here. 54% are saying higher, 41% are saying lower. Mm-hmm. The small minority in favor of staying the same, still there. That's a group of people who just does not like change. I am with you. And as I get older, I'm more with you every day. Awesome, awesome, awesome. And I'm seeing a consensus choice in favor of higher. Over to Maud. Let's see what happens. And I think I'm hearing a little bit higher. I'm hearing a little bit higher. And what Maud has done when she did that was she basically changed the stiffness of the spring, because the way this works is the mass of air inside the neck is bouncing up and down on this air in the bottle that's the spring. When I put water in there, it just has the effect of making that spring a little stiffer. Now check out this change. I have this bottle. I'm going to blow across the neck. And then what I'm going to do is I'm going to change the size of the neck by dropping in that little tube. I just made the neck bigger. I didn't change the length of the bottle, but it made the neck bigger. And so now the mass that's sloshing back and forth is now bigger. So I got this pitch. When I drop this in, is that going to make it higher or is that going to make it lower? We're going to launch a quick poll and see what folks think. All right, weigh in. So let's see what you got. Ooh, let's see. Oh my gosh. Higher and lower almost tied. And the distinct minority in favor of everything staying exactly the same is still with us. Higher and lower are trading places. It is a dead heat. It is a dead heat. Wait a minute, higher's out in front, except lower is coming on strong. Oh my gosh, this is crazy. The excitement is too much. Must stop. We are evenly split. We are evenly split between higher and lower. Only one thing to do, and that's do the test. So here we go. And I drop this in, and I blow again. Oh, lower, lower. So what I did, more mass sloshing back and forth makes it go a little bit slower. And that is a surprise to me, I got to tell you, because that is not the way I would necessarily anticipate it. But a little bit more mass goes a little bit slower. And next, for another oscillation that's a thing you can do at home, we're over to Brenna.
Yeah, so I have some 2 wine glasses here, and this is just water in here. It's got food coloring. But I'm sure you've seen a video or something, but if I...
Oh, very nice. And we're hearing that. And Brenna, you might bring that closer to your microphone so we can hear it a little more. Lean in. Lean into it. Oh, yeah. Well, that matches your shirt very nicely. I'd say nicely chosen liquid.
I dyed my fingers purple doing it, but that's fine.
Purple fingers are going to match the shirt. No downside.
Yeah.
Okay, so that's that pitch. But wait a minute. What's different about the second glass?
Well, are we gonna ask them?
Oh, no, we're going to say, like, what have you done? What have you changed?
Oh, I just added some more liquid.
Added some more liquid. So when she adds more liquid, here's the question. Is that going to make it higher or lower? We're going to ask folks to weigh in. Adding more liquid, does it make it higher? Does it make it lower? Oh my gosh, and we're having the horse race between higher and lower again. And a distinct minority of people who wants everything to stay exactly as it is. Thank you. You are my people. But anyway, oh, wait a minute. Higher is out in front. Higher has pulled ahead. Higher has pulled ahead. We're going to go ahead and stop the poll right there. Higher is out in front, but let's go ahead and actually do the experiment. Brenna, take it away.
So this is kind of interesting because
Whoa.
it's actually lower.
It's lower.
So all you higher people, you're wrong.
Oh, goodness.
You're wrong.
Brenna, we do growth mindset talk here. This is an opportunity for people to learn and grow. And what's different between the two cases, you added more liquid, and now it's not just the glass that's oscillating, it's all the liquid too. So
Yes.
now you did the same thing I did. You added more mass, and when you add more mass, what it does, more mass has to
Gives you a
vibrate.
lower pitch.
Lower pitch, lower pitch. Well done, well done. Okay, now we're going to do another resonance thing, and this is something that's kind of awesome. And I'm going to apologize to Maud because we had a little incident earlier that involved Maud getting several gallons of water on her, and you will see how that might happen. We have some water balloons, and water balloons like to oscillate. And they have a certain frequency they like to oscillate at. And if you drive them at the frequency they like to oscillate at, let's see what happens.
All right, so basically what we're going to be doing is dribbling this balloon. So I'm going to push on it, and it's going to push back on me, and I'm going to try to match that every time. And we're going to just increase that a little bit. And
And at some point, it starts to leave the table, which is kind of awesome. And this is something folks can try. And actually, if you don't fill it up too full, you're not in too much danger of getting wet when you do this. Awesome. But in Little Shop of Physics, whenever we do things, one of the things we like to do is make it bigger. And Brenna, let's go bigger. We've got a giant water balloon on the table behind Brenna.
Alrighty, guys. So here I have the mother of all water balloons. And if I press on it, it's pressing back on me just like Maud said. Well, if I match that pressing back, I can get this guy, even though he's huge, to leave the table. So let's go ahead and...
I'm seeing air underneath it.
it's going to jump off.
It wants to escape. It wants to have freedom. Let's do that one more time, Brenna.
Alrighty.
Let's see what you got. Because we're just matching your frequency, the frequency of the... And the oscillation gets bigger and bigger and bigger. And you can see it bouncing up in the center as Brenna is pushing down on it, and that thing wants to escape. It wants to head for the edge. You know what I think we should do?
What?
It wants to head for the edge. I think we let it go off the table and we see what happens.
Oh, all right.
Let's see if it bounces.
All right.
Giant water balloon rolling it to the edge of the table. We don't know what's going to
Challenge
happen.
accepted, Brian.
Here it goes. It's going to the edge, and it bounces, and now it's just oscillating on the floor. And it's more robust than you would think.
Except for the one that Maud...
Except for the one that
Yeah.
Maud was working with, one that was a little less robust. Now, if we have two things which like to oscillate, and we're going to look at two pendulums, and you couple them, they can transfer energy back and forth, and we're over to Maud for that.
so here I've got what we call a harmonic oscillator, and so I've got two little rubber duckies suspended from the same string there. And so I'm going to come around here, and I'm going to give the little green duck a little poke. And so the green duck is going to start to move, which makes the purple duck start to move.
And the green duck is stopped.
The green duck is stopping. It's slowing down.
Oh, wait,
And
now it's picking up speed. Now the energy's back in the green duck. What? And now it's back in the purple duck.
Yep.
And Maud, show them how you made this. How are they coupled together? So two pendulums, and what's connecting them?
So I do have, so here I've got one string, and that they're both, just the ducks are equal size down here. Just connected like that. I don't know how well y'all can see that.
Excellent. And so the string is actually connecting the two together, and it lets them exchange energy back and forth. And that's kind of foreshadowing for something we're going to see in our next segment where we talk about waves. But before we do that, another oscillation. We just have this tray which is using for, like, I think in dentists' offices. We managed to get a hold of this. And this is another one where we're setting up an oscillation, but it's a complicated and awesome oscillation. Over to Brenna.
Yeah, this one's just really cool. So I'm going to turn on this tray, and it's going to vibrate. If I shine a light on the side, you guys should be able to see some pretty awesome patterns. Are they coming through all right, Brian?
Yeah, that is looking awesome. That is looking really, really cool.
And
actually, I
depending,
would aim the light a little higher.
there we go.
There it is. Now I'm seeing the oscillations. That is good. And you can see the waves on the front surface of this. Another place where you can see this, we did this at home, like when our dishwasher is running. It makes a little bit of an oscillation, and you can make pans of water do this. We get this really fascinating oscillation in there. All right. And now we're going to segue, if I could use that word, from the idea of oscillations over to the idea of waves. And I need Maud's help with this. So Maud is going to grab the end of this long thing over here, and I'm going to grab the other end. All right. And Maud is going to go back to her station. I'm going to stay right here. And we're going to bring this down low where you can see what we've got. And what I've got here is this rubber tubing. And Maud's going to go ahead and pull it towards you. Pull it tighter. Yeah, just keep working. Yeah, that's it. That's it. We have a bunch of rubber tubing with some big nails inside here and rubber balls on the front, on the top. Now, if I take this rubber ball right here and I oscillate it, what it is going to do, it's going to make the one next to it oscillate. And it passes a little wave down the line, and it's over to Maud. And this is how I get from an oscillation to a wave. This little green ball right here likes to oscillate back and forth, but when I make it oscillate back and forth, it makes the one next to it oscillate back and forth, and it sends an oscillation down the line. And so it's like the thing that Maud did with the ducks. It's just a coupled oscillation, and it leads to a wave. And a wave is just an oscillation that travels. I think we can define it that way. So let's go ahead and set this down. And the next wave is going to be where you're over to Brenna, because the wave you know about, of course, is sound waves.
Yeah, so sound is a wave. So I have this speaker, and then I'm going to drag this guy over here. This thing is ancient, but it's basically just a generator for different sounds, so different frequencies, and they used these a long time ago. And I have a speaker here, doesn't have anything on it other than this ping pong ball, but if I turn on my frequency generator and then I crank it up a little bit, it's going to take it a minute. See if we can get it going. It's got to heat up a little bit.
Yeah, this is just like me, you know, old things. We just take a little bit longer to get warmed up and get moving in the morning. And so there's nothing wrong with that. Oh, look at that thing go.
And if I turn it up.
So that little disc is obviously vibrating. As it's doing that, it's pushing the ping pong ball, but hopefully it's also pushing the air. I should be able to hear it. Am I hearing anything?
Let me get it to where you can hear it.
Oh yeah, I'm hearing it now. Oh yeah, and it's still vibrating.
There we
So the
go.
vibrations of the disc are basically pushing the air and making that vibration travel through the air as sound. Awesome, awesome. That's how sound waves work. That's how sound waves work. And then Maud has another illustration of a wave, and this is on a stretched string, and you can use this. We just had a really, really long piece of rubber cord, basically. And we're going to shoot right down it, and then if Maud taps on it, she's stretched that cord out, and there's going to be a little wave that goes along the cord. So stretch it out, give it a tap, and there goes the wave all the way down to the end and back, and another tap. There go the waves down the string and back. And you can do that with a jump rope or a bungee cord or something like that. Oh yeah, that is awesome. Look at those waves going down and coming back. Awesome, awesome. Now, Brenna is going to do another sound demonstration with us, and she's got a little stadium horn. And Brenna, just go ahead and play the horn for us first.
Alrighty, I gotta take off my face shield.
Yeah, it's okay.
For
We
this.
got the shields between us. We're good. We're still protected.
We got some plexiglass. We're good.
We're good.
So.
Oh yeah, I can hear that. I can hear that.
I bet you can. So now I got some bubbles, and I'm just gonna make a bubble. I'm gonna blow it a little bit.
So there's a bubble on the end of the horn, and now, what? The sound wave is going through the bubble. Let's see that again.
Right through it.
So it's not the air that's going anywhere. What's going places, it's just the wave. And the wave goes through the bubble.
There we go.
One more time.
Alrighty.
And then go ahead and see if you can hold it for a little while. Awesome. So Brenna's blowing a bubble. And then play in the horn. Keep it. Oh, one more time and keep playing it. Hold that note. All right, let's see it. Awesome. And the wave goes right through the bubble and keeps on going, which is amazing. Now, there's another way you can make sound waves travel. They travel through the air. But for Maud and Brenna to talk to each other, we have generated this extremely high-tech communication system, and you can do this. Check it out. Each one of them has a paper cup connected to a string, and they're pulling the string tight. And so that they can go around our plexiglass shields, I'm going to hold in the middle with a rubber band, and I can make it turn a corner without being lossy. So you folks are going to pull it tight, and then go ahead and you can talk to each other.
Who wants to talk first, Maud?
I got you.
All right.
Hi, Brenna. How's it going?
Pretty good, Maud. It's going good.
And then say something really, I'm going to ask Brenna to cover her microphone and talk really loud into the cup and pull your cups tighter so we get a better transmission of the sound. And it's going to go over to Maud and she's going to put the cup over her microphone. Brenna talks really loud. Let's go.
Little Shop of Physics.
Awesome. And we can pick it up over on the microphone. And that was an appropriate sound to be making. Of course, it's the sound of Little Shop of Physics. And it's going right through the string. And you can try this. And I would encourage you to do this. Check it out. It's just a long string connecting two cups. You can use cups. You can use cans. And I can make it turn corners. And you want to turn corners, don't do it against something hard that absorbs the vibration. Hold it with a rubber band. And if you hold it with a rubber band, you can turn as many corners as you want. Awesome. That is our high-tech communication system in the Little Shop of Physics. We just need enough strings. We can send signals out to all of you folks. Next piece of the puzzle, Brenna has got another piece of string connected to a cup, and this is something everybody should make at home. Your parents will love this.
So this is my favorite because I love chickens, and we're going to make some chicken noise makers, or as we like to call them, chicken cluckers. So really all you need is a cup and a string, and you poke a hole in the cup. I just used a pen and then feed the string through with a paper clip. And you can see more in depth how we make these on our TikTok, so you should definitely check that out. But if we take a wet sponge and we whoop.
Awesome. That's pretty chickeny. That's pretty chicken. But you got different species of chickens. Wait
I
a minute.
do.
This is the metallic chicken.
This is the robot chicken.
I love robot chicken.
I have the party chicken.
The party chicken.
Party chicken sounds more healthy than the rest. And then I have
Oh my gosh.
the
This
big
is
papa chicken.
Oh my gosh. That is a frightening chicken. That's like its Tyrannosaurus Rex ancestors is what that one is like. That is fantastic. That is fantastic. When we were getting ready and thinking about oscillations, Emma, who works with us, suggested that she did a thing with water in the bathroom, and in the bathtub. And water in the bathtub likes to slosh back and forth, and it's an oscillation. And it's an oscillation, this really kind of a wave that travels from one side of the tub to the other. So it's a wave thing. But it's got a certain frequency it likes to go at, and if you push it back and forth at that exact frequency, if you match it, you get a dramatic effect. And we're going to try this with a fish tank. We have a little rubber duck, and I think it's named Franklin after Rosalind Franklin. Is that right? Mm-hmm. Awesome.
Yep,
Let's see it.
Franklin.
So Maud, tell us what we got.
So I'm
Look
just
at
gonna,
that wave going back and forth.
just gonna go real nice and slow so you can see just the one wave. If I start going like a little faster, push a little harder, it's kind of rough seas.
Poor Franklin.
can
Oh!
Oh, Franklin's over. But if I start doing shorter, like you start to get that one wave right in the middle. And if I just come on this side.
I mean, look at that. You're making different kinds of wave. We call those standing waves inside the tub. So next time, bath time, I'm saying Set up standing waves in the tubs, and you can just tell your parents, I'm doing science. Oh, look at that. Let's do that. Oh, my gosh, look at that. Huge waves, and she's just oscillating very gently, but exactly the frequency the tank likes to oscillate at and gets that dramatic effect. That's that resonance effect that we talked about. Awesome. Now, if you want to do a gentler wave in a container thing, the thing that drives the wave is the gravity. That goes up on one side, gravity pulls it back down. But if you have two different liquids of similar but still different densities that don't mix, you can have a wave that is driven more gently, and so a wave that travels more slowly, and we're over to Brenner for that one.
So here I have my cereal container. Probably you have something like this in your house. And I have my funnel so that I don't make a mess, and my purple water. I'm going to pour in some water. And I don't even think I need the funnel.
Go straight. Do it. All right, and what's next?
Then I have some oil here, and I'm going to gently pour this on top. And they aren't going to mix.
All right, and I'm seeing a layer of oil on top of the water. Awesome.
All right, let's see how that is. Oh, I can add a little bit more water.
Oh, I like that as pretty as that goes in.
Yeah. All right, and then I'm going to seal this guy up tight, which kind of leaked a little bit, but that's okay because I got a towel. And if I tip it on its side, woo!
Oh my gosh, and let's look at that wave. Oh, look at that wave going back and forth. Nice, and that is awesome. Look at the waves crashing inside that container. And that's just a little oil, little water, in a pasta or a cereal container. That is delightful. That is something folks can try at home. Oh my gosh, look at that. And Brenna is making some seriously rough seas going on there. Awesome.
There we go.
Thank you much.
Of course.
Now, we have that giant water balloon in the Little Shop of Physics that you saw earlier. And we said it would be cool to drop things on it and see what happens. And when you drop things on it, you can actually see waves in the balloon. And so we pre-recorded something, but we just got a giant balloon, filled it with water, put it on the floor, and dropped things on it and took movies on iPhones. This is something you could try. Just got to get a big balloon. Where do you get big balloons? At the party store, obviously. So let's see a little video of dropping things on a giant water-filled balloon. Awesome, and look at the waves. When you drop something on it, it sends waves through the balloon. Oh, look at that wave. Awesome. It sends a wave right through the balloon, and you can see it go. And so we can see the wave motion really, really well. It's just a way to be able to watch the wave, and it's a wave of the water and the rubber. And I would encourage you to make a water balloon. And if you have a phone that can take slow motion video, you are good to go. You are good to go. Oh my gosh, look at that. Look at that wave. Look at that wave. That is awesome. That is awesome. And that is a bowling ball. And then two balloons, and they're each doing a wave. That is fantastic. That is fantastic. And they're each doing a wave, and they're each doing their own kind of individual oscillation, which is fantastic. A little orange balloon and a giant purple one. And it's that purple balloon that ended up getting Maud a little bit wet, kind of like earlier. Okay, now we're going to do our grand finale. And the grand finale is we're going to make a wave, and we're going to do it with a spark. Now here's a device right here, and this device is known as a Tesla coil. And if I take this and turn it on, it's going to make a spark out of the top. And you can see the spark coming out of the top here. Now what we're going to do with the spark out of the top is this. We're going to take that spark and we're going to turn it on and off. And we're going to turn it on and off basically in time with music. And when I do that, we'll hear the music. So I'm going to do this. I'm going to go ahead and put the little music output into my phone. So I'm going to start by playing a song on my phone, and you will hear it. I got the music going. Now I put it in the headphone jack. You're not hearing it, but now you're going to hear it. I'm going to turn on the spark. And the music is coming from the spark. This is basically lightning. Lightning makes thunder because you heat up the air and it expands. It makes a sound wave just like the speaker pushed the wave to make the sound wave. And check it out. If I do this, no spark, no sound. No spark, no sound. And the spark is basically making musical lightning. We're just turning the spark on and off in time with the music is what we're doing. And that's our grand finale. We've made a wave by using electricity in the air. Next time, we're going to talk about this. What comes out of here, in addition to sound wave, there's also light waves, and I can pick up the light waves at some distance, and I can get that signal. One of the things we're going to do next time, on the next episode of Little Shop of Physics Live, we're going to talk about light and color. But before we go, I want to say thanks to Brenna.
Bye, guys.
With the container and the oscillator. Let's give us one more wave. Like rather than wave with your hand, wave with a wave in a container.
Come on,
There
Ryan.
we go. We're waving with a nice purple wave and the oil in the water, and then we're over to Maud. And what is Maud going to wave with?
I
The
can
fish
wave
tank
with
is already
Franklin.
there. You go. We can wave with Franklin in the tank. There it is, back and forth. The tsunami in the bathtub. Something you need to try. And my name's Brian Jones. We'll see you next week on Little Shop of Physics Live. Thank you very much.